This is Team Powerhouse presenting our idea for Smart India Hackathon 2025. Our problem statement ID is 25095. The problem statement title: Research and redesign a sport equipment commonly found in sport industry and utilize Fusion software to reimagine its design. Team: Smart Education. The category is Hardware. Team ID is 70029. The team name is Powerhouse. Our challenge was to take a common piece of sport equipment, research it, and redesign it using Fusion software. We chose to focus on a crucial but often overlooked component, that is, the skateboard truck. To begin, let's understand the part we have focused on. A skateboard truck is what connects the wheel to the skateboard deck. It's a critical component that allows the board to turn and handle impacts. As you see in the diagram, a skateboard truck has several key parts: the base plate, which mounts to the board with screws, the hanger, which holds the axle and wheels, the kingpin and bushings, which are essential for steering and turning. For our project, we focused our redesign efforts especially on the two main structural parts, the hanger and the base plate. The generative design process allowed us to completely reimagine these two components for maximum performance. Our solution is a lightweight generative designed skateboard truck. The goal of our project was to create a high performance skateboard truck that is significantly lighter than the existing models, meeting the demands of both local and the Olympic riders. For any skateboarders, a lighter board means better performance and greater agility, especially when performing tricks. We aim to reduce the mass of the truck and then validate our new design through a rigorous analysis to ensure its strength and durability. Next is our technical workflow. Now let's dive into the technology and the process we follow. We use Autodesk Fusion 360 to redesign the skateboard truck from the ground up. Our primary tool was the generative design feature. This isn't your traditional design process. Instead of drawing the part ourselves, we provide a software with a set of goals and constraints. We defined the preserved geometry, which is the area that must remain unchanged for the truck to function, like the holes for the mounting bolts and the space for the axle. We also specified the obstacle geometry, which tells the software where the design cannot go. Finally, we applied the loads and the forces that a skateboard truck would experience during the use. From this information, Fusion 360's generative design engine generated from many different design outcomes. We analyzed these options based on two key factors: mass and minimum factor of safety. Our main goal was to drastically reduce the weight of the component. We explored 4 different materials for our generative design: 6061T6 aluminum, A356 aluminum, ALSI 10 mg aluminum, and carbon fiber reinforced polymer, that is CFRP. After generating and assembling the design, we compared the mass to the existing steel model. The difference was remarkable. The existing steel truck weighs 1081.33 grams, while our new generative design model in 6061T6 weighed only 241.237 grams. That's a massive 77% reduction in mass. Analysis and validation. After designing the model, we used Fusion 360 simulation workspace to analyze its performance. We performed 2 key analyses: static stress analysis and model frequency. In static stress analysis, we applied the same loads and constraints from our design phase. This analysis helped us understand how the component would react under stress. We looked at 3 main outcomes from this analysis. Number 1, stress, von Mises. Number 2, displacement. And the third one is minimum factor of safety. Looking at our graphs, you can see that while the existing steel model had decent stress and displacement values, our new design with 6061T6 and CFRP showed superior performance, particularly in minimum safety factor. This indicates that our new design is not only lighter but also stronger and more durable. Next, we performed a model frequency analysis which helped us understand how the part vibrates at different frequencies. This is crucial for performance and preventing failure. The analysis is similar to static stress analysis, but we specified the number of vibration modes to analyze. The results show that our new designs have good vibrational characteristics compared to the existing model. Based on all this analysis, we concluded that 60626 aluminum was the ideal material for this project. It provides a great balance of low weight, high strength and high safety factor and is more cost effective option than some of the other materials. Manufacturing and prototyping. With our design finalized and validated, we move to the manufacturing stage. We use the additive manufacturing option with Fusion 360. First, we sliced our model, which converted the digital design into layers that a 3D printer can understand. Then we brought the design to life on a Flashforge Adventure 5M Pro 3D printer. The 3D printing process was the perfect way to create the intricate geometries of our generative design. Once the parts were printed, we did a bit of post-processing and then assembled them. We even fitted a prototype with wheels and tested it. In summary, our project demonstrates that using generative design and additive manufacturing, it is a highly feasible way to create a significantly improved product. By doing this, we achieved a 77% reduction in mass, increased the durability and safety of the truck, made the production process more efficient and minimized the material waste, making it more environmentally friendly. The analysis clearly shows that 60626 aluminum is an excellent choice for the next generation skateboard. This concludes our presentation on the topic lightweight generative designed skateboard truck, and this is Team Powerhouse presenting our idea for Smart India Hackathon 2025. Thank you.